Without precedent in the historical backdrop of modern humankind, the magnetic North Pole leaps toward the South Pole, and vice versa. Our reality will be turned upside down for some time, and scientists are meticulously trying to determine what the impending magnetic pole shift will mean for the Earth. What is certain is that the process can no longer be stopped. The signs are alarming, and the pole shift may have already begun. Magnetic pole shifts, also known as geomagnetic inversions, have occurred somewhat frequently in Earth's history but on geological timescales, making the phenomenon normal for the planet but a rarity for humans. Magnetic pole inversions likely occur every 200,000 to 300,000 years. The last complete pole inversion happened approximately 780,000 years ago. This inversion, known as the Bruns-Machiyama inversion, took place an unusually long time ago. Scientists suggest that the next pole inversion may have already begun. If the magnetic North Pole leaps toward the South Pole and vice versa, Earth's magnetic field undergoes a drastic realignment. During this transition, it significantly weakens for a period, leaving our civilization vulnerable to an increased risk of solar storms. Normally, the magnetic field reliably captures particle streams from the Sun, but when it weakens, more charged solar particles can penetrate deep into Earth's atmosphere, potentially causing damage. If this occurs during a peak in solar activity, as is currently the case, the consequences could be severe. Experts warn that a massive solar storm could cripple our entire modern civilization. The span of a pole shift can range from 1,000 to 10,000 years, making it both an eerie and fascinating event. A pole shift means a complete magnetic inversion of our planet. North becomes south and vice versa. Humanity has never consciously experienced this process, and we have no clear understanding of what a pole shift will feel like. It may seem as if nothing changes, or we may face significant disruptions, including large-scale failures of technological systems. Although the magnetic field is not essential for human survival, its impact on life remains largely unexplored. Scientists believe that animals use the magnetic field for navigation, and as mentioned earlier, the field protects us from solar particle streams. These particle streams would not pose a problem for the planet itself, even if they occur at longer intervals and in concentrated bursts. However, our modern civilization is at risk due to its dependence on technology. A pole shift is likely not an abrupt process. It may take between 1,000 and 10,000 years. During this time, the magnetic field weakens and becomes more chaotic, with the poles repeatedly shifting and wandering unpredictably before eventually realigning. Pole shifts occur due to changes in the flow patterns of molten metal in Earth's outer core. This is where the magnetic field is generated through an effect that scientists call the geodynamo. Influenced by thermal convection, Earth's rotation, and possibly external cosmic factors, the polarity of this geodynamo changes, leading to a shift in the direction of the poles. Current fluctuations in Earth's magnetic field are concerning. Over the past few centuries, the magnetic field has lost about 10% of its strength. Scientists are alarmed that this weakening continues and appears to be accelerating. For some time now, a region of significantly weakened magnetic field strength has been developing over the South Atlantic. This phenomenon is expanding daily and, in the worst case, could create a massive opening in the Earth's magnetic shield. Satellites and electronic devices are increasingly exposed to cosmic radiation, and no one knows where this trend will lead. In the Northern Hemisphere, unusual changes have been observed since the 1990s. Since then, the magnetic North Pole has been shifting at an increasing rate. Initially moving just a few kilometers per year, its speed has surged to about 50 to 60 kilometers per year. At present, the magnetic North Pole is moving toward Siberia. While this still seems relatively northern to us, there is a considerable distance between the geographic North Pole and its current magnetic location. Scientists recognize multiple types of poles. Earth has a geographic North Pole, which is determined by the planet's axial rotation and remains nearly constant. Though Earth has experienced axial shifts in its history, such events are far less common than magnetic reversals. Additionally, our planet has a purely geographical North Pole at the top of the Northern Hemisphere. The magnetic North Pole, however, is determined by the Earth's magnetic field and is the most dynamic, wandering the most. The magnetic field does not surround the Earth statically. It fluctuates and varies over time. Are we experiencing a superchron? Some scientists are skeptical. Are we truly facing a pole shift, or is this merely a natural fluctuation? The last pole shift occurred 780,000 years ago. Considering that such events generally happen every 200,000 to 300,000 years, some researchers argue that long periods without a pole shift are just as normal as the cycles themselves. In Earth's history, there have been extended phases in which no pole shift occurred for millions of years. These are known as superchrons, and we may currently be in the middle of one. During the Cretaceous superchron, Earth's magnetic field remained stable for approximately 30 million years. A similar but shorter period of stability could be occurring now. The shifting of the North Pole may simply be a natural fluctuation rather than a sign of an imminent reversal. Some scientists argue that geomagnetic reversals are chaotic and difficult to predict, making long pauses between them expected. They emphasize that without further evidence, it is impossible to definitively predict a pole inversion in the next 10,000 years. What would a pole shift mean for our civilization? During a pole shift, Earth's magnetic field would weaken, temporarily leaving the planet less protected from space radiation. This could impact nature and potentially human health in ways that are not yet fully understood. However, it is certain that technological systems, such as satellites and communication networks, would be disrupted by increased radiation exposure. In addition to communication failures, we could experience widespread power outages. It is also possible that more animals would stray into unfamiliar areas. Whales could beach themselves, and large flocks of birds could lose their way. No one knows how quickly animals will adapt to the new conditions or whether their internal navigation systems will realign faster than our technology. The extent to which a pole shift would affect Earth's climate and environment is currently a topic of heated debate. We simply do not know what would happen if the magnetic south became the magnetic north, and vice versa. What is certain is that a pole shift would pose a significant challenge for modern society. Scientists are closely monitoring every change to assess potential risks at an early stage. How did Earth's magnetic field come into existence? It is truly a miracle. The magnetic field enables our planet to retain an atmosphere, which allows life to exist. Planets without a magnetic field, such as Mars, lose their atmospheres, if they ever had one. The geodynamo inside Earth is, therefore, a stroke of good fortune. Within Earth's core, the planet's rotation causes electrically conductive molten metal to move, creating magnetic forces. The Earth's core consists of a solid metallic inner core and a liquid outer core. Iron and nickel in the outer core are melted by extreme heat from the inner core, creating convection currents similar to boiling water. This motion of conductive liquid iron generates Earth's magnetic field. These flows create electrical currents. These currents, in turn, generate an attractive field. The Earth's rotation powers these convection flows into winding patterns. Researchers refer to this impact as the Coriolis force. Once produced, the magnetic field enhances the movements in the fluid metal, creating a stable cycle that sustains the geodynamo. The result is a global magnetic field surrounding the Earth, resembling a giant bar magnet, forming the North and South poles. These cycles have been well studied and are potentially explained by science. Despite this stability, our magnetic field remains a scientific marvel. It appears perfectly coordinated, and without it our world would not be what it is. The magnetosphere shields the Earth from the solar wind. The Earth's magnetic field deflects the solar wind, preventing it from directly striking the planet. The solar wind compresses the magnetic field on the sun-facing side while extending it on the opposite side, creating a long tail known as the magnetotail. Despite this incredible protective shield, the Earth accumulates large amounts of solar particles at the North and South poles, trapping them in pocket-like fields. These regions were named after their pioneer as the Van Allen radiation belts. In 1958, the astronomer James Van Allen observed for the first time how charged particles from the solar wind are captured and bundled by the magnetic field. Once trapped, these particles travel along the magnetic field lines from one pole to the other, gradually losing their charge. As a result, The Earth's inner atmosphere remains perfectly protected. However, if particles do manage to escape, rare events like the Carrington event can occur. During this massive solar storm, people in the 19th century witnessed one of the strongest geomagnetic storms of modern times. The sky appeared ablaze with colors, and sparks flew from the early telegraph systems. When intense particle streams leak into the Van Allen belts, they produce a display of colors known as auroras or polar lights. The aurora borealis forms in the northern hemisphere, while the aurora australis creates the southern lights. Typically, these phenomena are only visible in extreme northern or southern latitudes. In 2024, a particularly intense solar particle storm struck the Earth, making the northern lights visible far beyond their usual range. Some auroral lights stretched as far as the Mediterranean region. People on the tropical Pacific island of Hawaii saw the spectacle for the first time with their own eyes. In the southern hemisphere, Australia and even South Africa were thrilled by the unexpected polar lights. Click the subscribe button now to be the first to see all our new videos.